Okay, with great responsibility comes great power, or is it with great power comes great responsibility? Clearly, Spider-Man is very disappointed in us. So conversions. So we're going to learn how to convert, and you might be tempted to say, "I already know how to do this. I'm going to do it my way, and I'm going to ignore your way," and that's totally fine. Actually, it's not totally fine. You should definitely do it this way because as we go through the course and we do stoichiometry, balancing equations, gram to mole conversions, all that fun stuff, we're going to use this conversion method. So sometimes this is called the factor label method, and sometimes it is called dimensional analysis. And depending on who you talk to, it could be called the conversion factor method. So I don't even know what it's called these days. So I'm not going to give it a name. If I give it a name, I will probably use the name interchangeably. So it all means the same thing. But here's the exciting thing about it. As soon as you know two things that are equal, so for instance, I know that 1 inch is exactly 2.54 centimeters. And actually, that's defined in law, so that's exact. So if you're keeping track of sig figs, that has an infinite number, and that has an infinite number, even though it looks like it should be 1 and 3. Or maybe I have a something like 1 gallon of gas is exactly equal to $2.09 and 9 mils, let's say. So that's something that could change depending on the gas station. But as soon as I know two things that are equal to each other, and I'm going to start with this one here, I can write two conversion factors. And to write a conversion factor, you just have to write one thing over top of the other thing. And how do you know which thing to write on the top? And the answer is, well, you don't until you have to use it. And when you do a conversion, you can only pick the correct one. So how do you do a conversion? Well, you take the number to be converted. So maybe it's a length and either centimeters or inches, and I multiply it by the correct conversion factor. So correct conversion factor. So if you are saying, well, how do I know which is the correct conversion factor? Right, grasshopper. So, well, here's what I'm going to show you in the next slide, how to figure it out. Okay, so maybe we're going to do a conversion. So let's say we've got 13.8 inches, and we need to convert it into centimeters. So how do we know which is the correct factor? And we could just go ahead and try each one of them, right? So we could take 1 inch and on the top, and we could put 2.54 centimeters on the bottom, and we could try it the other way around, right? We could say 13.8 inches and multiply by 1 inch on the bottom and 2.54 centimeters on the top. And the thing to look about it is if you look at the units here, you've got inches on the top and the bottom, so they cancel out. And what do they leave you with? They leave you with centimeters. So that looks quite promising. In fact, if you look at this one here, you can't see which one I'm pointing to. If you look at this one here, it's going to have inches times inches over centimeters. And at the end of the day, right, nothing's canceling out here. So you're going to have square inches over centimeters. And if I want centimeters, I really don't want squared inches per centimeter. So I'm going to cross this out and say that's just crazy talk, right? So the correct conversion factor is the one that gives you the correct units at the end of the day. Almost always what you can do is just line them up. So those are the units you want to get rid of. So on your conversion factor, you just put the units you want to get rid of on the bottom, and everything else goes on the top. So all I need now is a calculator. Before I do that, though, I probably could go ahead and count significant figures. This has got 3. Now you might say 2.54 centimeters and 1 inch. That has 3 and it has 1, but that's actually not correct because those are exact. They actually have an infinite number of sig figs. So at the end of the day, right, what is the lowest out of 3, infinity, and infinity? And the answer is 3. So we need a calculator. So let me grab a calculator. Okay, I got my calculator here, and I'm going to press these buttons. Can you hear them? 13.8 times 2.54. Okay, don't need to divide by 1. I get 35.052. So that is not the right answer. Bad calculator, right? So my calculator gave me way too many digits. How many do I need? I need 3. So I need the 3, the 5, and the 0. And everything else can just get pushed away. So because I'm chopping off a 5, I'm going to do the round up trick, right? So I'm going to take the 0 next to it and round it up. I'm going to add 1 to it. So it becomes, instead of 35.0, it becomes 35.1 centimeters. So I could go ahead and box that answer, I suppose, and maybe I should have boxed the 3 significant figures as well. So that would be how you would convert, using the conversion factor method, inches into centimeters. Good job. Okay, so you should try one. So maybe you've got 83.0 centimeters and you want to convert it into inches. So I could just kind of write it like that. Can you use the conversion factor method and convert it for me? So pause the video and do it, and unpause me. It's easy to do on video, it's hard to do in real life. And we'll compare notes, see if we get the right answer. So ready? Okay, I'm back. So here's how you would do it. So you would start off with what you want to convert, and you would multiply by the correct conversion factor. So out there in space, right, you've got 1 inch, and you got 2.54 centimeters, and you know they're equal to each other. So one goes on the top and one goes on the bottom, and we can go ahead and actually, I think I can cut that out. So I'm going to take that 2.54 centimeters, and I am going to, I made a copy. I'm going to drag it down to the bottom. Why to the bottom? Well, those centimeters I want to get rid of, so I need to get centimeters down on the bottom, and the inch, I'm going to go ahead and copy that and drag it, wrong thing, there it is, to the top. Very good. And what does that do? Well, that gets rid of centimeters, those pesky units I didn't want, and it gives me inches as my final answer. So I'm going to go ahead and just, I've already canceled, so let me get rid of that nonsense. I'm going to write inches down here. And I need a calculator again, so I'm going to grab my very delicious TI-83 Plus and clear. I'm going to type 83.0. My calculator actually doesn't care about the 0.0, but I'm going to type it in anyway. I'm going to go times by 1. Actually, I'm not going to do times by 1 because I know times in it by 1 won't change it, so I'm going to hit divide. And then 2.54, and my calculator, oh my gosh, it gives me 32.677165535, and would probably give me more digits if I could read off the side. So how many of those are legit? Not that many, actually. So 83.0 has 3 significant figures. Okay, why 3? Well, the 8 and the 3 definitely count, and that 0 on the end, did it count? Did I do it right? Yes. So because it is trailing, it depends. If there's a decimal point, it does count. If there's not a decimal point, it doesn't count. There is a decimal point in there. It's 83.0, so it counts as 3 sig figs. So at the end of the problem, I need 3 significant figures. So my calculator says 32.677165535. A whole bunch of nonsense like that. So I'm going to keep the 3, the 2, the 6. I'm going to remove that 7 and everything that comes after it. So that is going to be 32 point, I'm removing a 7. So that means that I round up the number next to it. So a 6 rounds up to a 7. So that would be 32.7 inches to 3 significant figures. Hey, well done. You did a great job there.